Welcome back to Inside the Factory. I'm joined today by Harlan and Sasha. No, today we have some new guests on the show. Maybe we'll start with Zach, if you'll introduce yourself to the audience.
Sure. Hi, my name is Zach Krohn. I'm the product line manager over in the generative design group at Autodesk. I've been here for about 12 years. Was an architect beforehand, before I joined up with the company. And I guess we're going to be talking about design automation today.
And Saul.
Hello everyone, my name is Saul and I'm originally from New Zealand, so apologies for the accent. If there's any slang that sneaks out of my mouth, then we'll try and refine. I'm also an ex-architect, having lived and worked in Australia and the UK, sorry, New Zealand, the UK and Canada before I moved here to Boston in the US. And I am the product manager for Dynamo. So it's my remit to sort of guide the development and the evolution and the trajectory of Dynamo moving forward to make it work better for all of you guys and girls.
Thank you both. Welcome to the show. Again, for everyone, I'm Aaron. Today, as Zach said, we're talking about automation, a little bit different twist on our heretofore Revit-centric theme. So let's start with you, Zach. Talking about automation specifically, can you differentiate this area of computational design as compared to, say, generative design?
Sure. So what's the difference between sort of automation and computational design and generative design? We could throw in a couple of other ones there, like parametric design. There's sort of a word soup that goes around about a lot of these terms. I think a couple of the things that we're really talking about with design automation versus generative design is, first of all, both of them are sort of methodologies and not necessarily sort of products or specific technologies. But automation is really this idea of, you have an idea of what the outcome is that you want, you know pretty exactly what it looks like, and you're trying to get there faster. You kind of know the process and you're speeding it up. And we can talk about some examples of that. But sort of the generative design approach is more of, sort of the performance specifications, or sort of the behavior that you want to have. You don't really know quite what it looks like for sort of a formal outcome. And there's sort of more of an exploratory aspect of it, where you're looking at, given some constraints and given some outcomes that I want to have in terms of performance, what are the ways that we can solve that problem? And it's sort of open-ended that way. And again, with automation, it's more like, I need to put labels on all of these rooms. And they need to start at 1 and end at 100. And it's kind of like, let's just speed it up. As opposed to something where we're looking at a sort of a design space and trying to understand the interrelationship of pieces like that. I mean, that's sort of very sort of high level kind of talking about the different relationships between those things. Really just about automation and generative design. We can get into computational and parametric too if we want to.
Yeah, and I'll say as one who used to be consulting with customers quite a bit, we would, when Dynamo first came to be, and other tools like it before that, the conversation with customers was always around the twisting towers, the cool looking things that you might do in terms of massing or exploration. But what we would go to the customer and talk about was removing all the tedium from their work process, because really that's the business value, right? Where do they spend their time? They spend their time often, the bulk of it, in construction documents. And so what if we could just sort of remove a lot of that? So with that in mind, Saul, why would I automate something? How would I get started with that?
Right, so to automate something using a process or an application such as Dynamo, it's like you mentioned, Aaron, the tedium. So if you're sitting there and you're not really engaging your brain so much, but you're finding yourself just clicking your mouse button, a few thousand times, this is probably a really good candidate for automation. So you can think of it as like a recipe. So, you need a recipe to bake something or to create something in the kitchen, just the same way that you want a recipe to sort of automate a piece of the AEC puzzle. So like Zach mentioned, you could do this with just placing some things such as room tags. You can also do that through examples of like, hey, I just really want to visually understand or interrogate my model a little bit better. So potentially something along the lines of like, I want to get every single wall and I want to get every single door on that wall and just make sure that their parameters match. So something like fire rating, for example, is a good candidate. So maybe you have some contractual obligation, something that you just have to tick off. It's not necessarily requiring brain power. It doesn't necessarily require you to think about it too much. You kind of just have to do it. So any candidate along those lines is really good for automation. It's a really good candidate because your expertise is better suited elsewhere. And this will be a literal time-saving endeavor. So if you build a little routine that simply either matches those parameters, or if you want to interrogate it, you can color something in the 3D context of Revit, for example, just to better understand the context space of what you're trying to interrogate, to make a decision based off that. You don't necessarily need to get to that place through manual process. You can get there a lot faster through something like automation.
We're going to come back to that in a minute, but I think we should set the table here first. So Zach, how does Dynamo work with Revit specifically?
How does it work with, how does Dynamo work with Revit is, in some ways it's a really interesting question. In some ways it's really simple. When we first started building Dynamo, we were building it basically like a third-party organization. Like, we didn't work at Autodesk. And in fact, the very first stabs of it were made by somebody that didn't work at Autodesk. Ian Keogh started sort of poking around at this when he was working at Buro Happold. And the whole idea of how it interacts with Revit is through the public API. So the public API, people are not familiar with it, is the application programming interface. So not all pieces of software have an API. More and more and more, that's becoming sort of the standard for most professional software. But it's basically an interface on any kind of application that allows sort of another machine to talk to it. So rather than having something that's a graphical user interface, the GUI, which is the thing that most people interact with Revit through, of pushing buttons and selecting things, this is just sort of a socket that you can plug another computational engine into in order to sort of work all the buttons. And so that's a publicly available thing. It's been around for years. It wasn't there when Revit first came out. In fact, Revit, when it first came out, very purposefully didn't have any way for people to customize it in that way. It was very much built around this idea of everybody has the same Revit, and it's all built the same so that you go from desk to desk to desk to desk, and you're going to have exactly the same experience. Somewhere in like 2007-ish, I don't know. Actually, Aaron, you might know this date too better. But there was a point at which it was introduced. It started with things like structural framing, I believe, were the first things that were basically opening up the application to be interacted with from outside. And it's grown and grown and grown. And now there's a very sort of robust set of interfaces for people to write additional tools to interact with Revit. And Dynamo just sits on top of that and just sort of, does the marionetting of the application through that interface. And in that way, it is not developed really with anything other than what another skilled programmer from outside of the company could build and have it interact with it. So that method of interacting with Revit is sort of it's a public feature. Other people can do it. The way that Dynamo does that is also the same way that Dynamo interacts with Civil 3D. It's the same way that it interacts with robot structural analysis. Other developers and customers have used Dynamo to interact with other products that are not Autodesk tools. There's some tools out there to interact with Tekla. And there's some tools to interact with, I'm spacing, so what are some of the other ones out there?
There's a customer-built 3ds Max integration as well. Sorry, Maya, not 3ds Max. Right. And so like the technology of Dynamo is fully open source. So anybody can take it and apply it anywhere they see fit, on the proviso, as Zach has said, that there is an API facing on top of that. So the cool thing about the Revit interaction is that typically now APIs are provided with different toolkits, but we're also seeing an expression of new Dynamo nodes coming through from new Revit features that come down the line as well. So case in point, recently Path of Travel is a new feature inside of Revit that is also now expressed as Path of Travel tools inside of Dynamo.
There's actually another aspect of that too, of how does Dynamo interact with things, which we didn't really do anything to talk about sort of what Dynamo is, and I don't know if we want to sort of go back and sort of talk about that, but the basics of what Dynamo is it's a graphical expression of computational concepts. It's kind of simpler than that, and it's more complicated than that. most of the time when people want to do sort of logic or rule-based design where they say, if this condition is met, then do this, those sorts of operations, you generally need to be a computer programmer. You need to be able to actually sort of speak in one of these languages like C# or Python or these other things. And what Dynamo provides is a set of sort of graphical interfaces. So we're going back into the GUI versus the API, the graphical interface, to be able to sort of build out hierarchical events in sort of a flow diagram that allows you to sort of do these sorts of computational practices where you say, monitor this situation. If this is a condition that you see, do this kind of operation, or adding two numbers together, all those sorts of things. We could share some images. If you want to check out some of these things, you can go to dynamobim.org to sort of see some examples of it. But all of that is to say is that the general way that people interact with Dynamo is sort of through this graphical interface that allows them to do sort of logic in order to create certain events. After having sort of described it that way, there is a whole other way of doing Dynamo's interaction with Revit, which is headless, which is you aren't actually interacting with those node and wire diagrams in this hierarchical graphical interface. There's actually a way that you can take existing workflows that you've made with Dynamo, and you can essentially bottle them up, and then you can just sort of fire them off to a little Dynamo engine to sort of say, like, thank you for that little package. I will now execute it. You don't have to see anything with it, and it'll return the data back into Revit. That's the Dynamo player. And that is a different way for Dynamo to interact with it, in that it's essentially this headless engine, which is just executing pre-calculated things. One other way is generative design in Revit, which we released in April, goes one step further of basically the Dynamo definition, which was already sort of calculated. It goes into Revit and it scoops up, and it sucks up a bunch of data that you might have specified that you need from Revit, and then it takes that sort of like a little packaged lunch, like a lunchbox, and sort of takes that all out and runs out into 5 or 6 separate processes that are completely outside of Revit, and goes, execute, and then brings back all of that data for you to inspect and then decide if you want to pass it into Revit. So we're actually in the process of trying to rationalize all these different ways, because sort of over the years, we've come up with a couple different ways to sort of do this execution. And we're going to be looking at sort of ways to sort of make all of these a little bit more sensible. But there's a couple different ways that it does it.
So let me break that down. So for someone who's a user like me and who's not a coder, there's pre-API, which just means you can use it the way it's built. Good luck. Then there's the API, which we're very fortunate with Revit in particular, has been a requirement for basically any new feature for years. So there's a pretty robust set of APIs for Revit, which I could now customize the software from if I can code. Or there's a tool like Dynamo, which allows me to, without necessarily knowing code, certainly in a more visual way, I can begin to customize using those same APIs under the hood. And then there's generative design, which begins to surface that, and the Dynamo player, which begins to surface that kind of thing in the Revit environment directly, if I don't want to go anywhere near a Dynamo or the APIs or any kind of coding, and I have someone that can do that for me. In our context, you would probably agree, especially with Revit and Formit, the Dynamo player is more relevant from an automation standpoint, perhaps, than generative design. Like if we were talking about how we might put this to use for your average user in a firm.
So Aaron, to your point, a couple of examples for this. So Dynamo Player is a really good way to sort of consume the logic that somebody else has created. So for example, you have a model and you just want to interrogate it and find out what is in there. So maybe you have some QA or QC routines that you want to spit out a whole bunch of different data to Excel, just for your, say, project manager, just to have an understanding of what's going into that model, or your BIM manager to understand if that model is up to standards. So there's a way to do, say, fire and forget graphs, where you literally just click a button, run the routine, and it does something and sends it somewhere, which is great. There's also a more interactive model. So if we're talking about Dynamo as being like building these graphs that contain a bunch of different logic and do things, there is also sort of a halfway step using the Dynamo player that allows a user to have a selectable inputs. So for example, you have a graph that maybe wants to place entourage around your model, and it randomizes those, but you need to give it somewhere for it to place those things in the first place. So as a user, you might say, I want to place like people on this floor or this walkway or within this room, and you have the ability to select that. So it simplifies the interface. So if nodes and wires are potentially a little bit too far, then there's this sort of halfway process where you can still derive a lot of power and have a little bit of customization and leverage the hard work of somebody else who's built that graph in the first place. But we also see a really interesting sort of like migration path or pattern with Dynamo as well. So we see a lot of users who started in sort of traditional modeling paradigms. They're clicking buttons, they're using features inside like Revit, for example, and then they want to sort of automate some of their processes. So they get into Dynamo and they start playing with that. They start to automate some of the tedium, come full circle out of their lives. They start to clean up their models using, say, QA/QC routines, and then they start to push further. So Dynamo enables this kind of like learning pathway to get towards the API level of developer in a way that is way more consumable for your average designer, because you start with this visual process where you're placing together little routes of logic and wiring them together to show the flow of information, as Zach mentioned earlier. It allows you to understand and interrogate at every stage of the piece how that information flows through your program, and also how to build that program in the first place. And once you've built a program in Dynamo, they're relatively easy to translate that into an actual Revit add-on, for example, using the API. If you wanted to start then learning C# or then learning DesignScript, which is our native language, or something like Python, because a lot of the processes that you're learning, the underlying sort of foundational steps, you're kind of learning by default when you start playing inside of the Dynamo space.
I'll be the first one to say that sort of working in Dynamo is not necessarily for everybody. There's lots of other ways that people work, and there's lots of people who know how to and are capable in sort of the traditional programming languages, and that population is growing. And what we look at are sort of like these sort of force multiplier kind of ideas of saying that, if you've got an office of 500 people, you're generally pretty lucky if you've got one person there who can develop software, who can develop plugins. And of the 500 people, if you've got 5 people who can do Dynamo stuff, that is, by my shrewd calculations, 5 times the number of people who can start accessing the API. The way that Autodesk works, like for better or for worse, is that we like to address lots of people. We do things that way. We try and change large swaths of how the industry works. And so when we look at these sorts of things of saying, how big of a splash can we make in a community? It's kind of looking at, well, if it's only 5 people out of 500 who are otherwise using the application, those are 5 people who are 5 times the number of people who could write regular plugins, but they're also enabling a whole other set of people who can use things like Player. And it's always this sort of balancing act, because sort of population dynamics are also changing all the time. It's really interesting to look at things like the number of people who are learning programming techniques in elementary school and high school. And there's tools like Scratch, which is it's a programming language. It's a visual programming language that is oriented towards 8 to 13-year-olds. And there's some wonderful sort of data on sort of like the hockey stick of that graph of users that happened basically around 2013 or 2012, I want to say. And it's that cohort of people who are now young professionals that have like sort of gone through, and like they're coming out, and now they're just sort of starting to sort of get jobs. And the number of people who are going to have cut their teeth thinking about design problems and thinking about how you interact with computers in a way that is really sort of fundamentally different than how, you know, this assembled group of people might have grown up doing it, I think is really super exciting. And it's something that we're kind of trying to keep our eyes on, to sort of say, like, does it make sense to sort of work more with emphasizing sort of traditional programming or regular sort of graphical interface, or these hybrid environments where you have a little bit of graphical and a little bit of sort of, you know, straight sort of abstract computational thinking. And I think that that's very much a moving sort of boundary or border right now.
You're directly addressing, I was going to actually steer you in this direction. So there's been this problem I think we've felt like we had to solve about how do we make this easier for folks to address and to move into the space. And you mentioned that earlier. However, you're also kind of suggesting there's an organic solution that's happening anyway, that as firms, you know, acquire new talent over time, they're going to acquire some of these skills without a retrain. But there's kind of some balance. We've had some innovators that have really embraced computational design many years ago versus those who are kind of still on the fence today.
I think it's always going to be, yeah. I mean, the trajectory of that question, if I understand it, Aaron, is, you know, what are we doing in order to make it easier for people to use these sorts of tools? And I don't want to say that, you know, population dynamics and sort of, you know, intellectual changes in the zeitgeist are going to sort of solve the problem for us. People are always going to desire to use sort of more stable, more accessible tools. You know, when they made the Good Grips kitchen implements, I don't know if you're familiar with this. It's a variety of kitchen implements that have big, beefy handles. And they were originally made for people who might have had arthritis or had a difficulty actually grabbing stuff. But they were enormously popular because they're easy to grip and they're easy to use. And everybody likes that. So
ergonomics,
even if you're enabled for doing things, you're going to want to have tools that are going to sort of be pleasant to use and accessible and approachable.
Yeah. And I mean, at all levels, right? There are scripts available right now from the Dynamo community that are able to just automate the most tedious, the most boring tasks that we must do, right? Like whether that's room numbering and renumbering and door numbering, et cetera. So even someone who doesn't have any exposure to this kind of thing can quickly take advantage of that. And on the other end of the spectrum, I have still traditional customers, but to your point, they're large enough that they have a few folks on staff that are just sort of naturally interested in these kinds of tools and have taken it upon themselves to begin doing automation tasks. And one customer, notably a few years ago, said, yeah, we're eliminating construction documents. I was like, wow, that's kind of a big step. He's like, well, we have 4 or 5 people who are pretty much just coding that full time. So we're going to spend our time, this is an architecture firm, doing design. We're not going to focus on that anymore. That's just a contractual deliverable for now. At some point, we won't even need to deliver those anymore, but there's no reason we should spend any time there. So I love seeing, you know, that's that whole spectrum of just, let's remove a few, you know, menial tasks from our workflow that actually consume way too much time, to let's just remove that phase that used to be the largest phase of our billings because it's getting in the way of us being architects.
Yeah, Aaron, to your point there, and talking about trajectories, like we're also trying to do that ourselves here inside of Autodesk with our own products, right? So not only are we trying to sort of help the industry, we're trying to help the industry by helping ourselves. So we're talking about like streamlining the experience of using Dynamo as well and trying to remove a lot of that tedium. So like we're kind of eating our own dog food in this kind of sense. So like we've put a lot of effort recently into trying to make Dynamo just easier to use and try to lower that sort of initial hurdle or initial barrier to entry. You know, when you kind of have to understand a bunch of baseline concepts before you can be successful, historically, we're trying to make that process, and we're sort of in the thick of the weeds in it right now, we're making that way easier. So we're starting to express way more learning content and way more sort of help content inside of Dynamo itself. So if you run into an issue, you should be able to self-serve and help yourself inside of that process as well. So we're looking to sort of move Dynamo into a place where it's like a really powerful backend as it currently is and can do really amazing things, but just really simplify that front interface so that users can get in and be successful right from day zero, as opposed to having to spend, slightly longer learning the content to get there.
Yeah, I mean, I can appreciate that as a user, as someone who was on the other side of that challenge. Is like we're all growing together, but it was such a niche thing early on, right? And it's becoming, as it becomes more mainstream, both the community knowledge and our ability to provide a better, easier to use solution needs to happen at the same time, right? Concurrently. Saul, so I know you're not limited to looking at Revit. So can you talk a little bit about cross-pollination of AEC design and development ecosystem? So we have things that have been developed with Dynamo, but they've evolved into something commercially viable, for example.
Yeah, so Dynamo expresses itself in multiple different places. So, historically, Dynamo was inside of Revit, and there was a decoupling event that happened a few years ago where Dynamo was split into Dynamo Revit and Dynamo Core. So my team is responsible for the core piece, which is like the common functionality between all of the places that Dynamo finds itself. So in that kind of context, Dynamo can be found in Format, it can be found in Civil 3D, it can be found in obviously Revit, you can find Dynamo in Alias. There's a bunch of other cool things on the horizon where Dynamo is going to find itself. And like I mentioned earlier, if you want to take Dynamo and you want to put it somewhere that you work in on a daily basis, then please do. Like we would celebrate that, and we would help you as much as humanly possible to do that as well from our side. So like we're really invested in sort of making Dynamo all that it can be and making it show up everywhere that it can. So in that vein, Dynamo is also like a strong sort of like product that glues a lot of the AC collections together, because if you learn Dynamo and Revit, then you also know Dynamo minus the potential bespoke pieces of the host application and every other place that you see it. So if you want to do cross-pollination workflows between, say, Civil 3D and Revit, you can do that and leverage Dynamo as part of that bridge. So we see Dynamo expressing itself in many different places, like we said, and some of those are slightly different ways. So we're looking to unify those, back to Zach's point earlier, to try and make that experience even more consistent over time. So Dynamo has been like a vehicle for users to kind of spin up their own companies, spin up their own commercially viable products. I mean, generative design that Zach mentioned earlier sits on top of Dynamo as the backing engine for it. So this is another feature that we now express using the power or the computational power of Dynamo itself. So Dynamo is also used by our own product teams as a prototyping tool. So if we talk about that journey or that trajectory that we mentioned earlier, where you start in a modeling environment such as Revit, and you move into Dynamo and potentially move up into sort of Python or C#, our own developers who are very well versed in coding languages actually still use Dynamo as a prototyping tool to sort of navigate their own explorations into new features that they're working on themselves, which I think is a really nice narrative, because Dynamo is not something you migrate beyond. It's a part of the puzzle piece that might be predominantly used by you, or it might also come full circle to be used as a prototyping tool to build even bigger and greater things.
Yeah, I mean, I think that there's just to sort of add on to that. It's kind of like you ever see those images of people sort of prototyping things out with Legos? It's like, I'm going to make my killer robot that's going to do whatever, and you assemble sort of the beginning part of a hand or something out of Lego, and then you slowly replace each part of that Lego hand with the machined fingers and the machined tendons and all the other things. You replace the rubber bands with steel or whatnot. I don't know if that metaphor sort of works, but the way that we've seen the trajectories for a lot of people's sort of Dynamo workflows is that it allows them to start quickly getting their heads around requirements and sort of functional things where it's just like, I have a project, I need to get it done right now. And as they find that, for instance, I'm trying to remember, I think like putting views on sheets or something has been something that people have done a lot of, they've prototyped it out, they've done some experimenting with Dynamo, and then as they realize that it's something that is used a lot in lots of different projects, they might replace pieces with things that are more efficient and eventually either like make a plugin. We've seen a lot of people using things like PyRevit is another example of like, we didn't make this tool. The guy that's done it has done a lovely job of making sort of this interface for people to go from sort of early coding steps to sort of have sort of Python-based plugins that they can work with. And a lot of these things are sort of built around this idea of how do we understand what the problem is that we're trying to solve, in order to A, get work done right now, and then B, to get that work done more efficiently. So it's like make it work and then make it performative is oftentimes a big step that people do. And we're very happy for people to sort of enter into computational thinking with Dynamo, and lots of people graduate. Like they sort of learn the concepts, they understand that automation is a thing that they can get their heads around. And at some point for many people, they move on to something else where it's like, now we've got something that's, more powerful. C#'s amazing. People do some astonishing stuff with it, and there's no reason not to use it. And a lot of what people do is they start off with a piece of Dynamo graph, and they replace pieces of it with self-coded pieces that make it more efficient and effective.
That's a reminder. This is the way all adoption works. So when I first moved to Revit, for example, it was like, oh man, I have to get a job out the door using something I don't understand. And it wasn't pretty, the first couple of times. But after a while, you develop a template, you start to understand, you start to build intelligent families that do what you want and fill out the schedules properly and so on. And after you've done a few of those, you kind of know what to build now, right? And I would say that it's the same thing with anything, but including computational design and automation. You're not going to get everything right the first time. You're going to realize, oh, I should have had it do this while I was having it do that. But that's part of the learning process. Right?
We get a lot of questions from people of, am I doing it right? And it's a funny question because it's like, well, is it effective? That's sort of like the proof of whether or not you're doing it right. There is a lot of elitism out there, frankly, about whether or not somebody is programming right or elegantly, or
best
in the best way. And there's some real pragmatism to doing this, of saying you need to get some work done.
Yeah. What is the problem you're trying to solve? Did it solve that problem? Yeah.
Yep.
And I would just add to that before you jump in, Aaron. It's like the best thing to do really is just to jump in, right? Just to start playing with it. And it doesn't have to be really, really hard. Like you can just browse the forums where there's probably thousands of different uploaded Dynamo graphs that you can take and play with and just run and see if they work for you. Or you can just take a graph that might only take 5 nodes to run and just interrogate your model. I mean, the easiest way to do this is like in the Revit context, you can collect all of the categories of stuff and just click the little green element ID inside of Dynamo. You can put like 3 nodes and it can cycle through that Revit document to find those things. So maybe you've got some missing piece of information in a massive large scale Revit model. You can actually go and interrogate that in 3 nodes if you want to, like missing pieces, unplaced rooms, these kind of things. If you need to find this stuff, you can.
Yeah, that's a good tip. Okay, so this question is a little bit of a curveball relative to what we've been discussing, but I guess it's natural. We have Forge. We've introduced design automation for Revit. We have some talk about will generative design move to the cloud, but in bringing us back to automation and perhaps using Dynamo for automation, Zach, can you see a future state where Dynamo's in the cloud? Or where any of this kind of functionality exists primarily in the cloud?
Yeah, the idea of is Dynamo going to be a web application? Is Dynamo going to be a service?
Or even automation, even kind of bigger than Dynamo, since we're
sure.
Not only talking about that.
Sure, absolutely, and automation in general. Yeah, I think automation as a cloud service is super exciting. I think that for Dynamo specifically, I think it's more of a question of when rather than if. Mm-hmm. A lot of the stuff that we're trying to do right now is most of our users are using desktop hardware, desktop applications, and that's where they're getting their work done. And we have a lot of work to do to actually make our own automation tools work great in those environments. And it is a priority really to sort of make that stuff work sort of where a lot of our customers are right now. That being said, we are looking very hard at how we can do services. We've done experiments of this in the past. we had some publicly available work with doing these customizers that were, you would author them in Dynamo and you would launch them up on the cloud and you could interact with them. We got a lot of good feedback on that. Generative design in Revit started actually as a web application called Fractal, which was also running on a Dynamo backend. There's questions of, there are limits that we had for the initial structure for how we built that, and we're reconsidering that for better, sort of more scalable ways for that to work. So we are looking at that, and we're working on that sort of service kind of architecture for it. The other things that are definitely on our horizon are looking at things like Forge design automation, which is its own thing, which is a handful of our desktop applications like Revit and AutoCAD and 3D Studio Max and Inventor, and I'm probably forgetting some other ones, that essentially have a Forge service associated with them, which is basically taking the desktop architecture and making it available as a cloud service. There's a natural sort of trajectory for us to be looking at with, can the things that you're running on Revit in the desktop with Dynamo, can those also be deployed as a cloud service through something like design automation? I think that's got a lot of promise to it for doing things like batch processing and facilitation of interoperability, a lot of those sorts of ideas. So again, I think it's more of a question of when rather than if. And we've got a lot of smart people actually thinking about it on a daily basis.
And outside of this context, Harlan and Sasha kind of discussed that a little bit in a previous session where we talked about let's move things to the cloud where they make sense, right? What should be computed on the desktop because it's simply faster to compute on the desktop should happen locally, at least in the near future, and things that can be uploaded or offloaded, and that process of sending and receiving is not actually worse than running locally, then we do that in the cloud and achieve greater efficiencies.
As Zach mentioned, we are exploring the idea of moving into Dynamo that can talk to things like Forge. And that would also, again, democratize the ability for people to get into that space. So if we're talking about currently on Forge, you really need to be one of these people who understand C# and JavaScript and a bunch of other really high-level languages. We're looking into this because we're particularly excited about, a Dynamo user today could simply use or upload a Dynamo script to be ran through the design automation framework. So, the example I had earlier with the QA/QC script, maybe you just want to interrogate your model, but maybe you have 100 models and maybe you want to run that at the same time and then aggregate those totals somewhere. You could do this in this future state when Dynamo talks to design automation through Forge.
That's cool. So we're about out of time, guys. Final thoughts around automation. What would you want the audience to take away from this discussion?
I guess I'll go first. I would say automation is not as scary as it sounds. And automation can be really, really simple at the same time. So just have a think about the kind of things that potentially frustrate you on a daily basis in your workflow, or the things, like I said earlier, that don't require too much brain power and just require a lot of sort of manual process and mouse clicks. And think about how you could potentially save a lot of time or so much time to, once again, take back to the place where I believe many engineers and architects want to be, which is thinking more holistically about sort of the humanistic application of architecture and design. So we want the machine to work where the machine works best. And many of these manual routines is not necessarily the best time spent for a human to do. So if we can automate some of these processes, it does give you that time back to really design and build a better world.
I guess the only thing that I would say, just sort of as a closing idea about sort of how people can think about automation is one of the struggles that I think internally we have about different workflows that we see or when things are happening is that we're hoping that we are not helping people do dumb things faster. and that's again, back to pragmatism. Sometimes there's things that you just got to do in order to get the job done, even though that's not the thing that's sort of the most important. And getting that dumb thing done faster is better than a dumb thing that you need to take more time to do. One of the things about computational thinking and the kind of thinking that you need to bring to automation is hopefully a different way of thinking about the problems that you need to solve, and thinking about things in terms of systems as opposed in terms of objects. Like, I need to make this object that is a building. Computational thinking and automation really gets you into a mindset thinking about systems integration. thinking about, do I need all of these systems integrating with them? And are the lived experiences of people who occupy them, are they interacting with these static objects that we've built and put out into the built environment? Or are they interacting with systems? And those systems include both the tangible and the intangible. Things like, how does circulation work? How does light play in this building, as opposed to just how many walls do I have and how many doors do I have? And I think that's a big opportunity with this way of thinking, that automation really is sort of it's kind of like a little keyhole that allows you to sort of an entry point into a whole other way of thinking about, I think, design and problem solving that I think is very exciting.
Thanks, guys. I learned a number of things. I mean, apparently marionetting is a verb from your usage earlier, but also, Dynamo is a great tool for getting us into automation. Automation's not, much like BIM as a concept, is not all or nothing. Just get started. It's not something that's in the future. It's happening now. Although from what you guys have both shared, it's got a bright future ahead too. So with that, thanks for your time, Zach and Saul. Thank you all for joining us. Please send us your questions. We'll see you next time on Inside the Factory.
Thanks, Aaron.
Yep. Thanks so much.